Hello my dear students, very good evening. So just there was a small technical issue in Hyderabad center, so that is why it was a delay by 5 to 10 minutes. Okay, I hope everything is clearly audible and visible to you, my dear students. Yes, Mr. Akash Pandey, very good evening everyone. So I hope everything is clearly visible and audible, right? Okay, so now main thing is how to revise the subject. First I will explain how to revise the subject. I think we have already done the regular course in GATE ESE. We have already done the regular course. So regular course we have taken up to 70 to 80 hours in regular course. Okay, so once you have done the regular course, concepts of and fundamentals I think you have cleared very easily, right? And then QRC program, I think you might have gone to QRC program. In QRC program, for each chapter we have summarized 1 hour. Okay, examination point of view, what we have to remember, what type of formulas we have to remember, what type of waveforms we have to remember, how to remember the formulas. Okay, so these type of tips I have given in QRC program. It is just a 5 hours duration program. So after completing of QRC program, you can write short notes. So write down the short notes, that will be very useful for examination point of view. You know, last 1 week or 10 days, you cannot go through the entire regular course. Regular notes is very big size. You cannot go through the entire concepts because you are at the end now. At the end, you can go through the QRC program. Even new students other than GATE ESE students also, if you are there on live, you can go through the QRC program from GATE ESE. Okay, it is just a 5 hours class. Okay, from QRC program you can write down the short notes. After finishing QRC program, you have to solve all the workbook numericals. Workbook numericals are very important for regular course. Okay, I hope already you might have solved the workbook numericals. Apart from the workbook numericals, you have to go to the remaining questions of previous GATE and IES. So previous GATE and IES remaining questions also you have to solve. And main thing here, in last 1 week we have to go through the GTQ. We started GTQ in the year 2021. Okay, so 2021 GTQ 2021, it is available in GATE ESE YouTube channel 2021, 2022, and now live is 2023. This is the current live session. This is the current live session, that what I am teaching now. Okay, so now we are going to discuss 22 to 23 current live session. These two sessions also it is available in GATE ESE YouTube channel. After completion of this, if you get a time tomorrow, go through these two cases. Very important questions are already given. GTQ course Power Electronics 2021 and 2022 also. Please go through these topics also in GATE ESE YouTube channel. It is available for everyone. Very important questions are given in 2021 and 2022 also. We may get repeated questions. I hope you understood. So don't neglect these questions. Apart from GTQ, you can refer some CTQ questions, some important questions already we have uploaded in GATE ESE YouTube channel. It is available open for everyone. So CTQ questions and some important questions of power electronics. Important questions of power electronics. So all these things are already uploaded in YouTube channel. Okay, so please go through those topics, right students? So main important point is last 1 week, don't lose your hope. Don't go through the entire regular course. Just go through the QRC program, write down the short notes, chapter wise what to remember, how to remember formulas and waveforms I have given to you, and go through the GTQ program, practice them. That is more than sufficient, right? Now let us go through the first question. Dear students, I think first question is already visible to you. All of you try to solve the first question. Remaining students, try to solve the first question. Try to solve the first question, remaining students. Very clearly it is given. Try to solve the first question. The weightage of GATE examination for power electronics varies from 8 marks to 12 marks. Okay. So here in a DC to DC converter shown in the figure, the duty ratio is adjusted to regulate the output voltage at 48 volts. That means the supply voltage is fluctuating with plus or minus 10%, 25 plus or minus 10%. So what is this converter here, dear students? What is this converter? So in question number 1, it is actually a buck converter. Just go through the circuit, not buck converter, just go through the circuit diagram. See, most of the times examiner does not specify whether it is buck or boost or buck boost. You have to remember the circuit diagrams. If you understand the position of inductance, you can understand what type of converter it is. Okay. So here if inductor is near the supply side, wherever we have inductor, so that is actually a low voltage side. This is actually a low voltage side and this is the high voltage side. So power flows from low voltage to high voltage side. So it must be a boost converter. So question number 1, it is actually a boost converter. See, examiner did not specify that it is a boost converter. Just looking at the circuit diagram, we have to come to conclusion that it is a boost converter, right? Now the supply voltage here, first note down the given parameters. Supply voltage is 25 volts plus or minus 10% variation is there. That means the supply voltage is fluctuating with plus or minus 10%. So that means 10% of 25 volts. So supply voltage is equal to 25 volts plus or minus 10% of 25 is 2.5 volts. So we have the supply voltage varying from 25 plus 2.5, 27.5, 27.5 to 22.5. So that means this is the maximum supply voltage and this is the minimum supply voltage. So the supply voltage is fluctuating in between 27.5 to 22.5 volts. So here the supply voltage is fluctuating. Now the duty ratio is automatically adjusted to regulate the output at 48 volts. So here the output voltage is 48 volts. So this voltage is fixed. Output voltage is fixed here. Okay. Now the question is, the maximum output power is 100 watts. It is given that maximum output power is 100 watts here. So maximum output power, so that is 100 watts. This is also given. Now find out the minimum value of inductance required to operate the converter in continuous conduction mode. So that means we have to find out the minimum inductance required for getting continuous conduction. Minimum inductance required for getting continuous conduction. And finally the frequency of the switch is 50 kilohertz. Okay. So dear students, so this is very easy question, very easy questions. So just try this question. I will give you 2 minutes. Yes, fatafat, make it fast. Yes, in QRC important is rectifiers, inverters and choppers. Mainly go through those topics. QRC program is given in Made Easy, Mr. Akash Mishra. Okay. Yes, Akash Mishra, definitely I will help you, don't worry. Dear students, please be on live, keep on saying your answers, be active, waiting for your answer, make it fast. Consider that you are writing exam now, okay. Yes, Raju Dolla has given first answer. Mr. Raju Dolla. Yes, Raju, your answer is right, very near. You came to near. Yes, Raju, very good. I appreciate you. Yes, yes, guys, make it fast. Make it fast. So, Mr. Raju has done it. Yes, Pranav, somewhere. Mr. Pranav, just think small. You will get two values for inductors. I will give a hint, my dear students. I will give a hint to you. So, just look here. The supply voltage is fluctuating 22.5 and 27.5 volts, right? So, see here. You take two cases here. So, first case, supply voltage 22.5 volts. Okay. Second case, supply voltage is 27.5 volts. So, we are having two cases. The supply voltage is fluctuating in between 22.5 and 27.5. Let us assume that in the first case the supply voltage is 22.5 volts. Okay. So, what is the corresponding duty ratio here? See, here our requirement is for getting continuous conduction. For getting continuous conduction, boost converter, what is the expression for output voltage here? The expression for output voltage is Vs by 1 minus alpha. Alpha 1 means it is the duty ratio in the first case. So, V0 is 48 volts, that is equal to 22.5 divided by 1 minus alpha 1. So, first calculate the value of alpha 1. Calculate the value of alpha 1. Yes, make it fast. So, you will get 0.53 I hope, right? Alpha 1 0.53. Just let me know whether it is, calculation part is left to you. Dear students, please verify the calculation part. Okay, whether I am doing right or wrong. Next, here in the second case, V0 is equal to Vs2 by 1 minus alpha 2. Once again, V0 is 48 volts. This is 27.5 by 1 minus alpha 2. So, here the value of alpha 2 is 0.427. So, this is 0.427. I hope you understood. So, when the supply voltage is fluctuating in between 22.5 and 27.5, the duty ratio varies automatically in between 0.53 to 0.427, right? Now, we have to find out the minimum inductance required for getting continuous conduction. Then given output power, what is the output power here? See here, output power, maximum output power is 100 watts. Formula for output power is V0 into maximum output current is equal to 100 watts. So, V0 is 48 into maximum output current, I mean average value. If you calculate this, you will get maximum output current. So, that value will be 2.08 amperes, 2.08 amperes, right? Now, we have to use the boundary condition here. See, we have to calculate the minimum inductance required for getting continuous conduction under all operating conditions. So, that is the question. So, whenever such questions are asked, say if they ask you critical inductance, or they are asking minimum inductance required for getting continuous conduction, or maximum inductance required for getting discontinuous conduction, in such type of questions, whether it is buck or whether it is boost or buck boost, all the cases we have to use the boundary condition. Do you remember in QRC program regular course I explained what is boundary condition here? Yes, dear students, tell me what is the boundary condition here. So, at the boundary, what did I say? At the boundary of inductive current, at the boundary of inductive current, average inductor current at the boundary is equal to delta L by 2. So, this equation is applicable only at the boundary. What is the formula for ripple in the in the case of a boost converter, the ripple is alpha Vs by Fl. So alpha into Vs by 2 into Fl. I hope you understood. Now what is the formula for IL here? In boost converter, inductor current, supply current both are same, and that is equal to I naught by 1 minus alpha. I hope you remember this formula, right? I have already mentioned, guys, you have to remember all the mathematical formulas I have mentioned very clearly in regular course as well as QRC program. Okay. Yes. Now this is IOB by 1 minus alpha is equal to alpha into Vs by 2 into Fl. So from this equation we get boundary current is alpha into 1 minus alpha into Vs by 2 into F into L. Dear students, actually this is the equation of boundary current. This equation is applicable under all conditions, whether it is buck or boost or buck boost. I think we have derived this one in regular course. I hope you remember, right? Yes. Now express the boundary current as a function of only one variable. You should have only one variable. If I have two variables, then it becomes more complex. Here alpha is variable, supply voltage is variable. We are having two variables here. I want to express the boundary condition as a function of only one variable. So how to write it? So here IOB is equal to, say, output voltage is equal to Vs by 1 minus alpha. This equation is applicable even at the boundary. Okay. So I want to express the boundary current as a function of one variable alpha. Remaining parameters are held constant parameters. So alpha into 1 minus alpha by 2Fl into Vs. Now multiply 1 minus alpha numerator and denominator. Say I am multiplying 1 minus alpha numerator and denominator, so that Vs by 1 minus alpha I am writing V naught here. So see here, in place of this Vs by 1 minus alpha, you can write V naught, right? So that equation can be written as alpha into 1 minus alpha whole square into V naught divided by 2 into Fl. So this is actually equation of boundary current. Just go through this equation. The boundary current is expressed as a function of only one variable. See, in this question output voltage is constant at 48 volts, frequency is constant, inductor value we have to find. Okay. Now alpha is the only variable parameter. So here as we have to vary the value of alpha here. Okay. Now how to find out the value of I naught here? So in the design case, what is the maximum output current? The maximum output current is 2.08 amperes. Okay. So substitute the maximum output current. So you can find out the value of L from this equation. So from this equation I can write L is equal to alpha into 1 minus alpha whole square V naught by 2 into F into maximum current. So in place of boundary current, I am substituting maximum current, because it is very clearly mentioned in the problem. This is the maximum output current that is possible, because maximum output power is given. From that we calculated maximum output current. So now you can calculate inductor for both the cases, right? You can use this formula now, right? So now we are having two cases here. Let us come back to the first case. Yes, dear students, I am erasing this again. Yes, now let us come back to the first case. Yes, in the first case you see here. Yes, how to calculate the value of L1 here? L1 is equal to, what is the formula here? Just go through this formula I have derived. to calculate the value of inductance. Alpha into 1 minus alpha whole square. So just look here, alpha into 1 minus alpha whole square, alpha into 1 minus alpha whole square into V naught by 2 into F into maximum output current. Maximum output current. I hope you understood. So first calculate the value of L1 here. Yes, make it fast. Calculate the value of L1. So alpha 1 is 0.53, 1 minus 0.53 whole square into 48 divided by 2 into, what is the frequency given? 50 kilohertz. 50 kilohertz into maximum output current is 2.08 amperes. So if you calculate the value of L1, how much it is? Yes, how much it is? I think you are getting 27 microhenry. You are getting 27 microhenry. L1. L1 is 27 microhenry. Similarly, calculate L2 here in the second case. L2, same formula, alpha 2 into 1 minus alpha 2 whole square into V naught by 2 into F into maximum output current. Okay. So L2 is equal to, alpha 2 is 0.427 into 1 minus 0.427 whole square into V naught is 48 volts. 48 volts divided by 2 into FL, frequency is 50 kilo, okay, into current is 2.08 amperes. Okay. So if you calculate the value, you will get L2 is equal to how much? 32.35, I hope. 32.35. Just check my calculations. 32.35 microhenry. Guys, you are getting two values for inductance. You are getting two values for inductance. Then which one we have to consider? They are asking, find out the minimum inductance required for getting continuous conduction under all operating conditions. Yes, what is the right answer? Yes. Yes, we are getting two values for inductance. So which one we have to consider, guys? Yes, tell me, dear students, which one we have to consider here? See, it should be applicable, the design of inductance must be applicable under every operating conditions. See, we have to consider the highest value of inductance. Consider the highest value of inductance, that is the minimum value required for getting continuous conduction under all operating conditions. So answer is 32.35 microhenry. Dear students, this is the right answer. The minimum inductance means you have to take the maximum value. So when you compare these two values of inductance, we have to consider the maximum inductance, okay, and that is the minimum value required for getting continuous conduction under all operating conditions. I hope the concept is clear, my dear students. Okay. So already we have summarized the concepts many times even in our regular course. Okay. So I hope the question is very easy, right? Yes. Just let me know from your comments. Yes, many students have done the right answer. Really I appreciate you. Very few students have confused. Okay. Yes, Hemant, your answer is right. Perfect. Aditya, good. Yes, very clear, I hope, right? Okay, students, shall we go back to the next question? Once again, let us summarize this question. Just let us summarize this question now. So see here, see, my dear students, they did not indicate what is the converter. So examination point of view, you have to remember the circuit diagram. Examiner may not mention whether it is buck or boost. He will not mention many times. You have to understand the circuit diagram. You have to remember the circuit diagram. How to remember the circuit diagram I have given in QRC program? Do you remember? Remember the position of inductance and remember the direction of power flow. You can recognize the converter. No need to memorize blindly. You cannot memorize everything. But how to remember? What are the hints to remember the circuit diagram? I have clearly mentioned in QRC program. Even in regular course I have given many hints to you. I hope you can recollect that one, right guys? So whenever inductor is there, that is the low voltage side, right? This is the, wherever we have inductor, that is a low voltage side. The other one is high voltage side. Power flow from source to load. So if power flow from LV to HV, it must be a boost converter. So how to recognize the converter, we have to understand first of all. See, sometimes examiner want to confuse you. He will give the circuit diagram like this also. See, sometimes examiner will give the circuit diagram like this also. We have to be very clear. Simply he will say like this. Pole, this is pole, okay. This is throw 1, right. This is the switch, this is throw 2, and then he will connect the like this. See, examiner will give the diagram like this also. Dear students, this is a boost converter, both are same actually. Examiner may give the diagram like this also. So don't confuse, okay. Now in this question supply voltage is fluctuating, okay. That means we are controlling the duty ratio automatically to regulate the output at 48 volts. That means as the supply voltage is fluctuating, the duty ratio is automatically varied to regulate the output at 48. So output voltage is fixed here, okay. Now they are asking, find the minimum inductance required for getting continuous conduction. Dear students, once again I am giving the hint to you. In any numerical problem, whether it is buck converter or whether it is boost converter or whether it is buck boost converter, in all the converters procedure is same, okay. So how, in what different ways examiner can ask you the question? Examiner will ask you the question in different way. Find the critical inductance, he will ask. What is critical inductance? It is the minimum inductance required for getting continuous conduction. That is what they are asking now. That is nothing but critical inductance. Find the minimum inductance required for getting continuous conduction. So we have to use the boundary condition. So whether it is buck or buck boost, all the cases, whenever a question is asked, find the minimum inductance required for getting continuous conduction. Find the maximum inductance required for getting discontinuous conduction. Find the maximum inductance required for getting discontinuous conduction. Right, then also we have to use boundary condition. So minimum inductance or maximum inductance or critical inductance, whatever may be the case, always we have to start with boundary condition. So students should understand the boundary condition here, okay. So where else we have to use boundary conditions? Sometimes examiner will ask you, find the load resistance for which inductive current is just continuous. Just continuous means at the boundary. Then also we have to use boundary condition, okay. So for every 2 years or 3 years, one time they will ask boundary condition. It may be related with buck or boost or buck boost. Choppers is very easy topic. Less content, less effort, you can gain more weightage. Dear students, understood? Choppers is very easy. Less content, okay, less content, easy to understand and more weightage. So never neglect the choppers. That is why I started with choppers only, right? Hope guys. Let us go back to the next question, right? So I hope everything is clear to you, right? Yes, Mr. Bipin, I asked you, you cannot memorize each and every formula, right? How many formulas you can memorize? What formulas we have to memorize, what not to memorize, I already gave in QRC program. If you try to memorize everything, you will forget everything. It is practically not possible. You have many more subjects. You cannot memorize each and every formula. No, right? Understand the boundary condition, you start, you will get it, right? Don't try to memorize every formula. In power electronics, 90% of formula no need to memorize. 90% of formula no need to memorize. Understand the concept, understand the strategy. By flow you will get everything. Only 10% formula, it takes more time to derive. So such type of limited formula you have to memorize in a proper organized manner. So those types of tips I have given in QRC program. What to memorize, what not to memorize, how to remember the circuit diagrams, everything is clearly in QRC program, right? Shall we go for next question? Okay. So this is what we have done in this question. So we used the boundary conditions for two cases. So we used the boundary conditions for two cases and we derived the value of inductance, right? So let us go back to the next question. Okay, right students? Yes, Akash Mishra, if you have any personal doubts, I will explain you later. Okay, if you have doubts related with these questions, I will explain. Please try to understand. Mr. Akash Mishra. Yes, go through the next question. Yes, all of you try this question now. Yes, this is also a boost converter. Supply voltage is 20 volts, output voltage is 60 volts, duty ratio is 0.6, inductance 100 microhenry, capacitance 100 microfarad, frequency 15 kilohertz. Find the peak value of current passing through the switch. Load resistance is 50 ohms. Yes, make it fast. Find out the peak value of current passing through the switch. This type of models also already we have practiced. Okay. Yes, come on, fast. Bipin, I hope you understood, right? Yes, Bipin, everything is clear, right? Yes, Modi, where is Modi ka Baba? I hope you understood the concept, right? Yes, go through this question also. See, this is another model of question. It may be buck converter or it may be boost converter or buck boost converter. I already said to you, see here, the peak value of current passing through the switch, or the peak value of current passing through the diode, same as the peak value of current passing through the supply. This is the supply, that is same as peak value of current in the inductor. Peak value of current in the inductor, that is nothing but I maxima. I have given the formula for I maxima. Yes, dear students, I have given the hint to you. I have given hint. You try this question. Yes, Ajay, Arun, right answer. Yes, fast. Yes, good. People are doing well. Very good. So definitely your confidence will improve. Yes, very good. People are doing well. Okay. Dear students, peak value of current passing through the switch, same as peak value of current passing through the diode, same as peak value of current passing through the switch. Okay, I will call it as switch. This is supply current, I will call. Current passing through the switch, ISW, I will call. Current passing through the diode, ID, I will call. This is IL. Okay. Now look here guys, I maxima is equal to IL average plus delta L by 2, right. This formula is applicable when IL waveform is continuous conduction. Same formula is also applicable even at the boundary. The same formula is also applicable even at the boundary, of course. Okay. IL average depends on the converter. Do you remember IL average is equal to I naught in buck. Boost converter IL average is equal to supply current. In buck boost IL average is sum of both. I have already given. Now let us see in this particular problem, given output is 60 volts. See, in boost converter, if it is continuous, see, we have to check again. If it is continuous conduction, in boost converter formula for average voltage is Vs by 1 minus alpha. Let us check this value. Vs is 20 by 1 minus, here alpha is the duty ratio, that is 0.6 given. So 1 minus 0.6. So what is this value here? Calculate this value here. Yes, make it fast. This is 50 volts, right? But the given average voltage is 60 volts. So here given V naught is equal to 60 volts, and that is greater than the value of Vs by 1 minus alpha. Therefore, IL waveform is discontinuous. IL waveform is discontinuous. Guys, what is the mistake you people will do? Sometimes some students will not verify this one. They will use this formula and they will get answer is 7 amperes. See, if student is using this formula, you will get the answer is 7 amperes, but that is wrong because it is discontinuous. People will not check whether it is discontinuous or continuous. Just they will use this formula because I have given in regular course. The moment they will ask you the peak value, straight away they will use this formula. People will get 7 amperes if you use that formula. So that is why I have given option A. Sometimes it happens, that kind of mistakes. Okay, so that is why be cautious. Especially in choppers, we have to identify whether it is continuous or whether it is discontinuous. That is the first point we have to identify, right? Now it is discontinuous conduction. Yes. If it is discontinuous conduction, what is the shape of IL waveform? Yes. If it is discontinuous conduction, see, this is the shape of IL waveform. This is one time period. Okay. See, when it is discontinuous conduction, this is I maxima, no? I maxima is same as the ripple. Look here, I maxima and ripple is same in discontinuous conduction. So because it is discontinuous conduction, the peak value of current passing through the switch is nothing but I maxima, that is nothing but delta L. Yes guys, calculate delta L, make it fast. Calculate delta L. Yes, make it fast. Calculate delta L. How to find delta L here in boost converter? Dear students, just apply KVL in this network when the switch is on. See, during the interval 0 to T on, the switch is on, right? See, apply KVL in this loop and find out the inductor voltage. If you find out the inductor voltage, you can calculate the ripple, right? KVL equation is minus Vs plus VL plus V naught is equal to 0. So VL is equal to Vs minus V naught. Okay, so Vs is how much? given Vs is 20. How much it is? Okay. So this is L into d of IL by dt. So 20 minus 60. Okay. Now from this you can straight away write d of IL is equal to minus 40 inductor voltage, okay, into dt by L. Okay, so here inductive current is increasing from 0 to maximum value. So integral 0 to I maxima, inductive current is increasing, and time limits is 0 to t on. So time limits is 0 to t on. I hope you understood. So from this equation we can straight away write I maxima or ripple, both are same here, 40 by L into t on. 40, ignore the negative sign, just ignore the negative sign. So how much you will get here? Yes, make it fast. Otherwise straight away you can use alpha Vs by Fl, that formula is also applicable here. Dear students, this is one approach, otherwise straight away I hope you remember this formula, right? You can use this method also. Instead of wasting your time, especially GATE examination, you can straight away use this approach, I hope. Delta IL is equal to alpha Vs by F into L. Yes, straight away use this formula. You will get it. Alpha is 0.6, supply voltage is 20, frequency is how much? 15 kilo, frequency is 15 kilo, inductance is 100 micro. So calculate this, 0.6 into 20, so you will get 8 amperes. You will be getting 8 amperes. Okay, so answer is 8 amperes. Option B is the right answer. Yes, Aditya Prasad. That is why we did not get it. Yes, Mr. Aditya Prasad. See, you can use this method also. See, I'll show you that one. How you got this formula? I got this formula during the interval 0 to t on, when the switch is on here. When the switch is on, this is the KVL equation. See, when the switch is on, this is the KVL equation. Unfortunately, I have given like this. Yes. See, actually, when the switch is on, this is the first mode. This is the second mode actually. Okay. So when the switch is on, you will get this formula. The same formula you will get. Okay. Second mode also you will apply, you will get that formula also. Okay, you can apply the second mode also. The same thing you can do like this also, students. See, second mode during the interval t on to tx. So during this interval, when you off the switch, the diode will on. So if you follow this method also, you will get the same answer, but this is the easiest procedure. Okay, just follow this method straightforward. Okay guys, answer is 8 amperes. So concept is clear? Concept is clear to you, right? Yes. Yes, Aditya Prasad Sahu, you are perfect. Yes, I can understand that. Okay, good. Yes, Aditya, you are right. Yes, Pandey, you can use that method also. See, This is the first approach. By using first approach you can derive ripple. By using second approach also you can derive ripple. But second approach is very time consuming method. So always use the best method. Okay, use the simple method. Yes, Aditya, you are perfect. Okay, so many persons have done the right answer. Good, very good. So go through the next question. Go through the next question. Question number 3. Yes, students. Yes, go through the question number 3. Make it fast. All of you make it fast. Yes, students, make it fast. Yes, Mr. Shivashankar, in the previous case that formula is applicable for discontinuous conduction also. Shivashankar, during QRC program I explained that point. Okay, that is applicable even in discontinuous conduction. Mr. Shivashankar, if you want you can derive that one. Okay. Yes. Shivashankar, I hope your doubt is cleared. See, in boost converter, I mean I am talking about the previous question, doubt of one of the student. The ripple in the inductive current, alpha Vs by Fl. This formula is perfectly right, whether it is continuous or whether it is discontinuous, this formula is perfectly correct. But it is not true in all the cases. Only in boost converter it is perfect, whether it is continuous or discontinuous, right? And this type of formulas no need to memorize, I have given some shortcuts how to remember the formulas in QRC program, even in regular course I said. Okay. Yes, go through the question number 3. Yes, make it fast. What is the answer? Yes, fast. Make it fast. Really, this is really wonderful question, dear students. This is really a wonderful question. One silly mistake you will do. Many students, 80% of students will do silly mistake here. Be cautious. What kind of silly mistake you will do? Understand? Yes. Yes, Mr. Hemant. Yes, Hemant, Modika, Baba. Who is that? Silly mistake. Yes, Dilip. Excellent. You are perfect. Mr. Dilip Ranjan has done the right answer. Arpit Singh is right answer. Yes, perfect. Yes. So, unfortunately, most of the students will say answer is option A. Generally, that is the mistake you will do. Okay. Yes, first of all, what is this converter? What is this converter? Yes, it is a buck converter. It is a buck converter. How can you identify? Inductor is here, low voltage, other one is high voltage, power flow from here. So it is actually a buck converter. So just remember the position of inductance, you can identify. Now look here, supply voltage is 24 volts. So it is actually a buck converter, right? It is actually a buck converter. Supply voltage is 24 volts. Now in buck converter, formula for output voltage is alpha into Vs if it is continuous conduction. Okay. So what is the value of alpha here? Alpha is 0.4 into 24. 0.4 into 24. What is that value here? 0.4 into 24. 9.6 volts you will get here. This is 9.6 volts. But given what is V0? Given V0 is equal to, directly you can write I0 into R. I0 is 0.695. 0.695 R is equal to 20 ohm, R is equal to 20 ohm. So given V naught is equal to, multiply that, how much you will get? You will be getting 13.9 volt, 13.9 volt. See, this is the given output voltage. So given output voltage is 13.9 and that is greater than alpha Vs. So here V naught is equal to 13.9, that is given, that is greater than the value of alpha Vs, and therefore IL waveform is discontinuous. IL waveform is discontinuous. Yes, IL waveform is discontinuous. So if it is discontinuous, we have to find out the peak to peak ripple in the inductive current. Yes, what is the formula for ripple in the inductive current? The general mistake what people will do is, buck converter, they will use this formula. This formula is applicable for continuous conduction. This formula is applicable for continuous conduction. It is not applicable for dear students. This formula not at all applicable for discontinuous conduction. Actually, how you got this formula? How you got this formula? See, alpha into Vs minus alpha Vs by Fl. For continuous conduction, what is alpha Vs? See, alpha into Vs minus. So what is alpha Vs here? This is actually V naught. This is actually V naught. Okay, so this is actually V naught. V naught is equal to alpha Vs if it is continuous. That is why you got this formula. That means if you remember this formula, now it is applicable whether it is continuous, whether it is continuous or whether it is discontinuous. Now it is applicable. Now this formula is applicable whether it is continuous or discontinuous. This formula, what did I say? V naught is equal to alpha Vs. So this formula is applicable whether it is continuous or even at the boundary. This formula is applicable whether it is continuous or discontinuous or at the boundary. So we have to use this formula. Many students will use this formula and get option A. So option A, I have given 2.88 amperes. If student is using this formula, you will get 2.88, and that is wrong answer. That is the general mistake people will do. So how to remember the formulas is important. Very, very clearly I have given in QRC program how to remember the formulas. This formula is applicable for continuous boundary. This formula is applicable everywhere. So better remember this formula. This formula is applicable everywhere, right? So from this formula, what is alpha here? What is alpha? Alpha 0.4, alpha 0.4, 0.4. Supply voltage is how much, dear students? Supply voltage 24, output voltage, this is 24, output is 13.9 by, what is the frequency? Frequency 10 kilo, frequency 10 kilo, okay, and inductance value is 200 micro, 200 micro. So if you calculate this, 2.02 amperes you will get, 2.02 amperes. So answer is option C. Yes, option C is the right answer. Option C is the right answer. So dear students, you should be very careful in GATE examination. Examiner know your weakness. What kind of mistakes we do, examiner already predicted your mistakes. Examiner already predicted your mistakes. Examiner already predicted your mistakes, so that you can gain the negative marks, right? So I hope numericals are very interesting, right? Yes, very good. Yes, yes, yes. Dear students, I have selected numericals wherever student is having some weakness. Okay, as per the experience I can understand generally what kind of mistakes many students will do. So there I have focused here. Okay, clear? Yes, Pandey, I hope it is clear, right? Aditya Prasad Sahu, you can use that method also. You can use even that method also to check whether it is continuous or discontinuous. Mr. Aditya Prasad Sahu, see another method for finding that one is calculate the boundary current. Okay, load current is given in the problem. Load current is given in the problem. If you calculate the boundary current, okay, formula for boundary current is alpha into 1 minus alpha into Vs by 2 into Fl. You calculate the boundary current. Okay, if I0 is less than the boundary current, then IL is discontinuous. Yes, you can also use this method. You can also use this method. Ultimately, you will get the same answer, right? Okay, interesting? Good. Okay, guys, go through the next question. I hope it is clear. Your doubts have been cleared. Okay? Yes. Now go through this question, dear students. We have done 3 numericals. Till now, we have done 3 numericals in DC to DC converters. Okay? And now in inverters, questions are mainly asked in square wave inverters and mostly PWM inverters and 3-phase VSI. So PWM inverters, it may be bipolar PWM, it may be unipolar PWM. PWM inverters are very important. Just go through this numerical. This is the output voltage of bipolar PWM single phase VSI. We are having 2 notches for 1 quarter cycle. We are having 2 notches. In the regular course I said how many notches we are having for 1 quarter cycle, that many additional odd harmonics can be eliminated. Okay, we have already done in our workbook also this model. Okay, so here we have to find out the fundamental amplitude of output voltage when you compare with unmodulated waveform. Yes, try this question. This is also very easy question. Okay, yes, try this. Yes, guys, make it fast. Yes, my dear students, I have given the formula for Fourier series. You know, summation of n is equal to 1, 3, 5 up to infinite Bn into sine of n omega t. Here An is equal to 0 because the signal satisfies quarter wave symmetry. The signal satisfies quarter wave symmetry. Quarter wave symmetry, An is equal to 0. Actually, in Fourier series you will write An cos n omega t plus Bn sin n omega t. This is what we write. Here the signal is satisfying quarter wave symmetry. See, because it is having quarter wave symmetry, An will become 0. We are having only Bn, and I have given the formula for Bn here. Wait, I have given the formula for Bn. So in a case of a bipolar PWM having 2 notches for 1 quarter cycle, what is the formula for Bn? I have given this formula in regular course I have given this formula in QRC program also. Examination point of view, you must remember this formulae. You must remember. Derivation takes more time. Okay. So when you answer the objective questions, especially in GATE examination, time is very important. Less time, you have to solve more numericals with more accuracy. Accuracy is very important. Time is very important. So examination point of view, you cannot derive the Fourier series expansion and waste your valuable time. So these are standard questions. For such type of standard questions, you have to memorize Bn formula. I will give the formula for Bn. When we have two notches, 4Vs by pi into 1 minus 2 into cos of n into alpha 1 plus 2 into cos of n into alpha 2 divided by n. This is for two notches. If I have three notches, minus 2 cos n alpha 3. Accordingly, you may have any number of notches, accordingly formula will change. I have given the general expression. If we have k number of notches for quarter cycle, you can expand this one. So this is the formula for Bn. Now I want fundamental amplitude here. Okay, so find out the fundamental amplitude B1 I want. Find out the value of B1. 4 into Vs by pi, okay, 1 minus 2 into cos of alpha 1. Substitute n is equal to 1 here, plus 2 into cos of alpha 2 by 1, n is equal to 1. Now alpha 1 and alpha 2 is already mentioned in the problem. Substitute the value of alpha 1 here. Here this alpha 1 is 23.62 degrees. 23.62 degrees. This is very easy question. This is 33.30 degrees. Okay. So if you calculate this value, you will get the value of B1 is, just a minute. If you calculate this, you will get 1.0684, 1.0684 into Vs. Okay guys. Okay, now what is unmodulated waveform, guys? What is unmodulated waveform? See, this is square wave. So this is nothing but unmodulated waveform. Unmodulated means square wave. So for unmodulated waveform, can you tell me what is fundamental amplitude here? Fundamental amplitude is 4 Vs by pi. So that is 1.28 into Vs. This is unmodulated. So what we have to find out now? As a ratio we have to find out. So we want to find B1 modulated. Compare with B1. B1 means fundamental amplitude. This is unmodulated. Compare with unmodulated. So what is this ratio? 1.0684 into Vs divided by 1.28 into Vs. So Vs will cancel in the numerator and denominator. So if you take this ratio, 0.839 you will get. 0.839, that is 83.9%. Okay, so that is the answer. Okay, so the fundamental amplitude of output voltage is reduced to 83.9% of unmodulated fundamental amplitude. So answer is 83.9. okay, answer is 83.9%. okay, it is reduced to. Okay guys, so if you have any doubts you can ask right now, I'll help you. Okay. Yes, Mr. Shubham. Yes, that is the mistake. That is the mistake people will do. Many persons have written 16.09. See, the fundamental amplitude is reduced to, I said. If they say it is reduced by, instead of to, small correction. Here language problem. Here language problem. See, here is reduced to I wrote. Suppose instead of to, they will write it is reduced by. It is reduced by how much? 100 minus 83.9, 16 point something, right? Yes. Then answer will be 16.1. Dear students, we should be very careful here. You should understand the sentence. The fundamental amplitude of the output voltage is reduced to TO2. It is reduced to 83.9. How much it is reduced by? It is reduced by 16.1. So in the question, if it is reduced by, then answer will be 16.1. But in the question I have given, it is reduced to. That means student know the concept. Student know the formulae. He remember everything. But the problem is grammatical mistake. Student is not understanding the question. Grammar, English. Understood? The fundamental amplitude of output voltage is reduced to 83.9%. Otherwise it is reduced by. In the question they have given it is reduced by means then it is 16.1%. So be careful here. Understood? Understood where you are doing? So you should be very careful in GATE examination, students. Sometimes you feel that I am getting everything, but examiner know everything. What kind of weakness we are having? Identify your weakness. See, you remembered the formula, you remembered everything, but unfortunately you don't know the meaning of this. So now I am teaching English here, grammar, right? We should be very careful with the sentence. Understand the sentence properly. Okay guys? The fundamental amplitude of output voltage is reduced to 83.9%. Suppose in the question they are given it is reduced by 16.1, then it is right. Okay guys? Yes, Modi. See, many students have done the similar mistakes here. Guys, many students have done the similar mistakes. They have written answer is 16.1. Be careful in GATE examination. Small mistake will go, 100 ranks you will go back. 100 ranks you will go back if you do small mistakes. In spite of knowing everything, you did not understand the question in a proper way. You understood? Where we are doing such type of mistakes? That is the reason I have given this question like this. Otherwise there is nothing here, already we have done in the regular course. But where student will do mistake? Understood? Yes, Modi, right. Perfect. Very good. Ajay, Mr. Ajay, Vikas, Sharma, I hope your doubt is cleared, right? Yes. Go through the next question. And one more, students, my dear students, if it is bipolar PWM, say, if it is bipolar PWM, multiply by 2. If it is unipolar PWM, here 1 we have tried. This 2 will be missing. That is the only difference if it is unipolar and bipolar, okay? Understood? Yes, Mr. Shubham, perfect. So we should be very careful here. GATE examination we have negative marking, okay? In spite of doing everything, in spite of remembering everything, unfortunately we are marking wrong because of this reason, right? So that is what I said. If you go through the, if you solve the practice many good questions, student will understand your weakness. Okay, if you do mistake, don't lose your hope. Okay, so that is why this year I did not frame two tough questions. You go through the GTQ 21 and 22, those questions are tougher than this. Because when I frame tough questions, students are losing the hope. So that is why too much tough I did not do this year. This is more than sufficient for GATE, I hope. If you go through the GTQ 2021, 2022, those questions are little bit tougher than these questions. That is why please go through the GTQ questions of 2021 and 22 also. Tomorrow you practice them. That question is also very interesting, right? Okay, students. Yes. The same kind of mistakes. Yes, Sharma, I hope you understood now. In case of unipolar PWM, here you will get 1. Bipolar PWM you will get 2. Unipolar PWM you will get 1. Bipolar 2. Unipolar 1. Easy to remember the formula also. These are the things we have done in QRC program. I am just reminding you, okay? Yes, go to the next question. Very simple question. Guys, this is very simple question. Very simple question. Yes, make it fast. Fatafat. Yes, fast. Very simple question. Yes, guys, make it fast. Very simple question. Yes, make it fast. This is actually very simple question. Yes. Yes, Aditya Prasad, you are perfect. Your answer is perfect. Very good. Yes, very good. Arpit Singh, good answer. Yes, Mr. Saurabh, Gajendra Sharma and Modi, just go through your answers once again. Understand your mistakes. Okay. Yes, it is very simple question. Yes, all of you look here. Now listen to me. Just listen to me. What is the peak blocking voltage of switch? See here, S1 and S2 are complementary switches. You cannot switch on S1, S2 at a time. If I switch on both at a time, it will short circuit the supply. Let us suppose that S1 is in the on state. When S1 is in the on state, S2 remains in the blocking state. Okay. Now what is the voltage across S2? Tell me. See, when S1 is on, minus, plus, minus, plus. So that means from here to here, 50 plus 50, 100 volts. So this 100 volts will appear here. So voltage across S2 is 100. When S1 is in the on state, see, from here to here, this voltage is 100 volts. The same 100 volts will appear across S2. So answer is 100 volts. Option B is the right answer. Guys, you understood? Option B is the right answer. Okay. So look here, all of you, whether it is single phase half bridge inverter, single phase half bridge inverter, or whether it is single phase full bridge inverter, or whether it is 3-phase VSI. Do you remember here what is this 50 volts? Vs by 2 is equal to 50. This is also Vs by 2. So Vs is equal to 100 volts. Here Vs is equal to 100 volts. Okay. Vs is equal to 100 volts. That is the answer. In all these three cases, the peak blocking voltage of switch, the peak blocking voltage of switch, the peak blocking voltage of switch is equal to Vs. So whether it is half bridge or full bridge or 3-phase VSI, answer will be same in all the cases. Okay. Yes, Modi, understood na? Yes, good. So whether it is half bridge inverter, or whether it is full bridge inverter, or whether it is 3-phase VSI, answer is 100 volts. Some students have marked 200 by pi. Some students marked 100 by pi. I'll tell you why I gave this option. Actually, here the waveform is square wave. The output is square wave here. Okay. You calculated fundamental amplitude. I did not ask you fundamental amplitude. You calculated fundamental amplitude. Maybe it is 4 into Vs by 2. Okay. 4 into 50. You will get 200 by pi, I hope. This is fundamental amplitude of output voltage. So that is why you might have done wrong. I did not ask you fundamental amplitude. I am asking the blocking voltage. Do you remember? In buck converter, the switch and diode must be capable to block the entire supply voltage. Okay. In boost converter, the switch and diode must be capable to block the output voltage. Buck boost Vs plus V naught. Definitely every 2 years there will be one question related with ratings. What kind of ratings? They will ask voltage rating, they will ask current rating. We have to design the ratings of semiconductor switches. Rectifiers, they will ask PIV rating. Such type of models, every 2 years we are expecting one question. That is the strategy we have done. That is the statistics we have done already. Okay. So next question. Yes, guys. This is also a very simple question. Yes, try this. Make it fast. Yes, Mr. Gajendra Sharma. It is 1 mark only. Such questions are asked only for 1 mark. Okay. Yes, it is also a very good question. You might have solved in workbook also, but small changes I have done here. Yes, make it fast. Yes, fast. Yes, students, look here. 3-phase voltage source inverter, we can operate in 120-degree mode or 180-degree mode. Here 180-degree mode means square wave mode. Load is star connected resistive load. Star connected resistive load. Resistance is 10 ohms. Each phase resistance is 10 ohms. Okay. So now we have to find out the supply current. We have to find out the supply current. Actually, how do you find out the supply current? Assuming that it is a lossless converter, use the power balance equation. Use the power balance equation. Equate input power is equal to output power. By using power balance equation, you can find out the value of supply current. I have given the hint. Now you try. Now you try. I have given the hint. Yes, try this. Yes, try this. Why you said 0? 0, how it is 0? I don't understand. Yes. Vs is 500 volts, dear students. Here, this Vs is not given, unfortunately. Vs is 500 volts. Please correct it. Correct the question. Supply voltage on DC side is 500 volts. Yes, make it fast. Yes, what is the right answer? Yes, yes, yes. Yes, right answer. Yes, Modi, your answer is right. Arun Kumar, Raju, yes, Aditya Prasad, your answer is perfect. Yes, very good. Mr. Pandeji, Harshit Mittal, small correction, there is wrong, it is wrong actually. Yes, now see here. Yes, first of all, what is the output power? It is a 3-phase, no? 3 times of phase current whole square into R. So this is the power loss in resistor. Whenever you calculate power loss in resistor, we have to consider RMS value of phase current. 3 phase means 3 times of RMS value of phase current whole square into R. How to find phase current? You know, line voltage RMS is equal to root 2 by 3 into Vs. Whether it is star connected load or whether it is delta connected load, line values are same. Examination point of view, you have to memorize this formula. I already said, guys, in QRC program, 3-phase VSI, what we have to remember? 3-phase VSI, examination point of view, you must remember the line voltage VRY. This is common for star load or delta load. And remember R phase for star connected. So these waveforms you have to remember for examination point of view, whether it is 180-degree mode or 120-degree mode. If you remember those waveforms and remember this formula, you can answer any question asked in 3-phase VSI. Now what is the phase voltage RMS? Line voltage by square root of 3, because load is star connected load. Okay. So now I can write it is root 2 into Vs by 3 volts. So now phase current is equal to phase voltage by load resistance, that is root 2 into Vs by 3 into R. So calculate the phase current here. So root 2 into Vs is 500 volts by 3 into 10. So that is equal to 23.57. 23.57 amperes. Calculated the phase current. So output power 3 times of phase current RMS is 23.57 whole square, resistance is 10 ohms. Okay. So after calculating this, you will get output power is 16,666.66 watts. So this is the output power. Now how to find input power on DC side? This is the power balance, this is DC side and this is AC side. So when you calculate the power on DC side, Vs into Is. See, this is the power on DC side. Output power is, this is the output power. Okay. So supply current average is divided by Vs is 500 volts. So calculate the supply current, you will get 33.33 amperes. 33.33 amperes. Guys, even if it is asked in single phase VSI, whenever they are asking DC side supply current, see whether it is single phase VSI or three phase VSI, whenever they ask DC side supply current, calculate the output power. Whatever may be the load, calculate the output power. Use the power balance equation, you can get the supply current on DC side. So answer is 33.33 amperes. Yes, right answers. Yes, very good. Many students have done. Perfect. Okay. See, same question, instead of star connected load, they are asking delta connected load. For delta connected load, line voltage and phase voltage are same. Okay. This is the formula for line voltage in the case of 180 degree mode VSI. Formula, you have to remember this formula, right? Remaining formulas no need to memorize. If it is 120 degree mode VSI, formula for line voltage is Vs by root 2. See, line voltage RMS is Vs by root 2 if it is 120 degree mode VSI. So these are the formulas you have to remember, examination point of view. That means it all depends on the preparation. What is our preparation strategy? What is our revision strategy? Okay. So if you go through the QRC program, I have given the revision strategy. Less time, how to remember many things, what to remember, what not to remember. You cannot memorize everything, right? It is impossible. Only limited things you have to memorize in an organized manner, and remaining things from the concept you will get it by practice. Okay, done? Okay, my dear students. Yes. Yes, Mr. Tiwari, why you got 100 amperes here? For which case? Yes, go through the next question. Yes, guys. Yes, go through the next question. Question number 7. Yes, go through the next question. Single phase VSI unipolar PWM is feeding an AC load with a desired fundamental frequency of 50 Hz. Amplitude modulation ratio MA is equal to 0.8. Frequency modulation ratio MF is equal to 8. What is the dominant harmonic frequency? So examination point of view, you have to remember this formula. So look here. See, single phase VSI, unipolar PWM. So I have given these formulas in the regular course as well as QRC program. What is the harmonic spectrum in this case? Harmonic spectrum. Do you remember? Harmonic spectrum, N is equal to J into 2 into MF plus or minus K, okay, where J is equal to 1, 2, 3 and so on, and K is equal to 1, 3, 5 and so on, and MF should be even integer. Why it is even integer? This concept we have done in the regular course. Okay, why it should be even integer? We have done the waveforms, I explained the concept, why it is even integer. Now this is not the time to discuss regarding that. Okay, yes. Now what happens when j is equal to 1 here? So first let us take j is equal to 1. N is equal to 2 into mf plus or minus k, and k is odd number here. 2 into mf plus or minus 1. Next 2 into mf plus or minus 3 and so on. Okay, and what are their frequencies? 2 into fc plus or minus f1. See, if you want nth harmonic frequency, I said n times fundamental frequency. So using that formula, I want nth harmonic frequency. Substitute n is equal to 2mf plus or minus 1 here, 2mf plus or minus 1 into f1, you will get 2fc plus or minus f1. I hope you understood. And this one is 2fc plus or minus 3f1 and so on. So this is actually the dominant harmonic frequency. Dominant harmonic frequency. What is the meaning of this? What is the meaning of this? See, the size of the filter and the quality of the waveform is mainly decided by the dominant harmonic frequency. So let us find out the carrier frequency now. So how to calculate the carrier frequency? So from this data given, mf is equal to fc by fm, and that mf, what is the frequency modulation ratio? 8. So fc is equal to 8 into modulating frequency. So see this formula, mf is the ratio of carrier frequency modulating frequency. So from this equation, carrier frequency is 8 times modulating frequency. And last question, what is the criteria to select the modulating frequency? Yes guys, answer my question. What is the criteria to select the modulating frequency? Modulating frequency is decided based on the requirement of fundamental frequency. That means modulating frequency is nothing but fundamental frequency, and fundamental frequency is 50 Hertz. It is already given in the problem. So 8 multiplied by 50, so 400 Hertz. So carrier frequency is 400 Hertz. Some students, the moment they got carrier frequency, they will answer 400. That is wrong. This is wrong. That is carrier frequency. They did not ask you carrier frequency. They are asking the dominant frequency. So dominant frequency 2 into fc plus or minus f1. So 2 into 400 plus or minus 50. Okay. So 800 plus or minus 50. 800 minus 50 is 750. 800 minus 50 is 750 and 850. So we are having two dominant harmonic frequencies. Yes, this is MSQ questions. Guys, here we are having two answers. We are having two answers. This is also right answer, this is also. So the MSQ. Okay. So we should be careful here. Two answers are correct here. Okay. Yes, please note down that. We are having two answers here. Both are right answers. Okay. Got it everyone, guys? So I hope you are experiencing very good questions, right? So what is the general mistake? Students should identify that it is multiple questions are their answers here, because when you are already practiced with MCQ questions having only one right answer, but in some of the numericals you may have more than two right answers. We are having two right answers here. It is multiple select questions. That means you may have two or more than two right answers also. Okay, perfect. Yes students, let us go back to the next question. I hope everyone understood this one, right? Yes, Roshan Kumar, it is carrier frequency. 400 Hertz is carrier frequency. Be careful. Unfortunately, people will mark 400 here. Some people will say 2FC means 800. That is also mistake. Okay? Yes. Suppose in the same question, see, in the same question, instead of unipolar, they have given bipolar. For bipolar, J into MF plus or minus K. I have given that formula also. You try that later, okay? Yes, next question. Yes, guys, next question. Yes, this is also very good question. Yes, now go through this question. All of you go through this question. Find the PIV of each diode. Yes, guys, answer this question. Find the PIV of each diode. It is also very good question. Fast. Find out the PIV of each diode. Yes. Yes, fast, fast. I am giving 2 minutes time. Yes, Aditya Sahu, you are perfect. Yes, good, good, good. So I hope you identify what is this circuit diagram. Yes, what about remaining guys? Make it fast. Yes, fast, fast. Yes, 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 perfect, perfect, good, good, good. Yes, yes, you people will be selected, good. Yes, very good students. Dear students, you have to identify what is the converter here. It is actually a voltage doubler. It is actually a voltage doubler. Voltage doubler circuit. Okay, it is actually a voltage doubler. In the case of a voltage doubler circuit, see here, assuming higher values of capacitance, this voltage is 2 Vm. This is charged with Vm volts. This is also charged with Vm volts. For the worst case, we have to design the values. Okay. Now, here also, let us suppose that in the positive half cycle, this diode is in the on state, okay, and this diode is in the off state. When this diode is in the off state, this diode is on, this will short circuit this terminal. So this Vm plus Vm, 2 Vm will get here. So, and that is the PIV. So PIV of each diode is 2 into Vm volts. Even in midpoint rectifier you will get the same. Vm is 230 root 2. Okay. So answer is 460 into square root of 2. Option B is the right answer. Okay. Right students? Clear? Yes, it is a voltage doubler. Yes, perfect. It is a voltage doubler. Okay. Yes. Everything is clear to you? Shall we go for the next question? We have discussed voltage doublers also in the regular course. Okay. So next question. Guys, shall I go for next question? Okay, very easy question. Yes. Yes, now see here. Guys, all of you see this question? See, common data question. Question number 9 and 10, the data is same. Yes, go through this one. All of you go through this question. Yes, fast. Expecting fast response. Make it faster. Yes, students, be faster. Yeah, you have only 1 minute time. Yes, Mr. Aditya Prasad Sahu, I already said in the introduction of the regular course, even though it is not there in the syllabus, basic things students should have idea. Even if it is asked in the examination, you cannot claim. Yes. Yes, what is the answer? Okay, now look here. This concept belongs to AC voltage controllers. AC voltage controllers. Yes, guys, look here. We are having two concepts here, mainly for inductive loads. I am talking for inductive loads. Okay, resistive load is very easy. Just go through the Bimra textbook, you will understand. I am talking about inductive loads. It may be RL load or any other load. Okay, you know impedance angle is tan inverse of omega L by R. Here first case, if the firing angle alpha lies between 0 and impedance angle, if firing angle is between 0 and impedance angle, in that case we get continuous conduction. We get continuous conduction. Do you remember in the case of rectifiers, I used to say beta is greater than pi plus alpha. That means if impedance angle is if firing angle is less than impedance angle, okay, if firing angle is less than impedance angle, beta is greater than pi plus alpha, we get continuous conduction. Continuous conduction means, what is the meaning here? See, continuous conduction means this thyristor will conduct for 180 degrees, this thyristor will conduct for 180 degrees, then only you will get continuous current. 180 degrees positive current, 180 degrees negative current. That means two anti-parallel SCRs will behave like a short circuit. That means you cannot control the output voltage in this case. Both will behave like a short circuit here. So if you observe here, output voltage and supply voltage are same in this case, in this condition, because it is continuous conduction. Output voltage, supply voltage, both are same. See, this is the supply voltage, output voltage also same. After reaching steady state, the supply current is lagging by impedance angle. Here pure inductive load, for pure inductive load, impedance angle phi is equal to 90 degrees. That means if the firing angle is less than or equal to impedance angle, it is less than or equal to 90 degrees, then it is continuous conduction here. The same case, it is lagging by 90 degrees. Supply current is lagging by 90 degrees, it is sinusoidal. Okay, so T1 will give the positive current, T2 will give the negative current. That means you cannot control here. Output voltage and input voltage are same. So each thyristor is conducting for a period of 180 degrees. Answer is option B. Each thyristor is conducting for a period of 180 degrees. Option B is the right answer here. You cannot control the output voltage. So here output RMS voltage same as supply RMS voltage, that is Vm by root 2, and this is the maximum possible output voltage. You cannot vary the output voltage here. You cannot vary the voltage. Our control is lost. Okay? And if you want RMS current, RMS voltage by impedance Z, that is the formula. But what happens in the second case? Yes, guys, they did not ask the question, just I am remembering you. If the firing angle is greater than impedance angle, suppose alpha is greater than 90, then you will get variable voltage here. Now in this case, this is our supply voltage, which is sinusoidal function. Okay, T1 forward bias in the positive cycle and T2 forward bias in the negative cycle. So alpha is greater than 90 degrees now. So this is alpha, this is 90 degrees. So alpha is greater than 90, this is alpha. So T1 begins here. See, whenever the load is pure inductor, see here current positive, this is the supply current. Here current positive, voltage positive, power positive. Here voltage negative, current positive, L is releasing energy. How much time it is storing energy? Same time it will release energy here. This is beta. So T1 is conducting alpha to beta. So what is the conduction angle of thyristor here? This is pi radians, pi minus alpha. This is also pi minus alpha. So conduction angle of the thyristor is twice of pi minus alpha. Conduction angle of thyristor. And T2 will conduct here. Again at pi plus alpha. At pi plus alpha, T2 will conduct. It will give negative current. T2 gives negative current. Okay. And if I draw the steady state waveform, what waveform we have after 2 pi? The same thing we have here. Here also T2. Okay. This is the supply current waveform. Understand? So you can vary the voltage in this case. You can vary the output voltage in this case. This is for the second case. Dear students, please go through the Bimra textbook for this concept. Refer Bimra textbook, you can easily understand. Refer Bimra textbook, you can easily understand for this topic. Okay? It is very easy for you. Even though it is not there in the syllabus, try to refer Bimra textbook. It is very clearly given. Now go through the next question, guys. So answer for this one is 180 degrees. We lost the control here because firing angle is 90 degrees here. See, when the firing angle is 90 or less than 90, you have lost the control. Output voltage and supply voltage are same. Here anti-parallel SCRs are behaving like a short circuit here. You cannot vary the output voltage here. I hope you understood. Right, students? Concept is clear now. If you have any further doubts related with this concept, please refer to the Bimra textbook. Okay? See, I hope it is not mentioned in the syllabus, but still if examiner want to ask, he may ask. So that is why don't lose your hope. Okay? Right. Go through the next question. Yes, it is related with the same data. This is also related with the same question. The same thing I explained. Yes. Which of the statements are true as per the data of previous question? The reactive power drawn by the load is maximum at alpha is equal to 90 degrees. How do you find out the reactive power here? See here, reactive power is equal to Vs into Is into sine of, understood? Here for continuous conduction, here lagging, fundamental angle is lagging by 90 degrees, sine 90 is 1 here. Actually this is fundamental current, fundamental I will take because supply current is having harmonics, this is sine 90. So this is actually equal to 1 here. Now what is the equation for fundamental current? You can go through the previous question, dear students. You can see this waveform here, small correction, yes, go through this one. Supply current is distorted with harmonics. See, when alpha is greater than 90 degrees, supply current is distorted with harmonics. I will give the fundamental RMS current here. You have to remember this fundamental RMS current, examination point of view. Supply RMS voltage by pi into XL into 2 pi minus 2 alpha plus sine 2 alpha. See, this is the formula for fundamental RMS current here. The supply current is distorted with harmonic components. So if you calculated the fundamental, it is like this, okay. Fundamental current is lagging by 90 degrees here. So from this only you can derive. So from this, what is the formula for reactive power here? Reactive power is equal to supply RMS voltage into fundamental current into sine of fundamental angle. This is the formula for reactive power. Fundamental angle is 90 degrees here. Fundamental angle is 90. That means it is lagging by 90. It is drawing the lagging reactive power. So supply RMS voltage into fundamental source current. Fundamental source current is this one, square it by pi into XL into 2 pi minus 2 alpha plus sine 2 alpha, sine 90. Sine 90 is 1, right? So this is already 1, remove it. Yes, now guys, this is the formula for reactive power. So here which is variable parameter here? By controlling the value of alpha, you can vary the reactive power. Now, do you remember in power systems, you might have studied facts, okay? Reactive power control, there it is used, reactive power control. This is nothing but TCR, thyristorized control reactor. In power systems we use facts. So by controlling the firing angle, you can control the reactive power, okay? Now when the firing angle alpha is equal to pi radians, what happens when alpha is equal to pi? 2 into pi, this is 0, so reactive power is 0. So at alpha is equal to 180 degrees, see here, at alpha is equal to pi radians, of course 180 degrees, what is the reactive power? 0, okay? So reactive power is minimum here when alpha is equal to pi radians. What happens when alpha is equal to pi by 2? When alpha is equal to pi by 2, reactive power is maximum, okay? So what is the right answer in this case? Yes guys, tell me what is the right answer in this case. I think options are given already. So that means here reactive power is minimum here. At alpha is equal to pi by 2, reactive power is maximum here. If you want, you can verify from this. So what is the answer here? When alpha is equal to pi radians, reactive power is 0. When alpha is equal to pi by 2, we get maximum reactive power. That means the converter draws maximum reactive power when the firing angle is 90 degrees. When the firing angle is 180, reactive power is 0. So what is the answer for this question? Option A and B for question number 10. Option A and B is right answer, okay? Option A is right answer. Reactive power drawn is maximum at alpha is equal to 90. Reactive power drawn by minimum at alpha is equal to 180. This is also right. This is also MSQ question, okay? So A and B is the right answer. I hope you understood, okay? Please don't lose your hope, okay? Generally they will not ask you. Suppose if they want to ask for worst case, they will ask, okay? Because it is related with power systems. You know, power electronics related with power systems. Actually, in power systems you might have studied facts. Okay, we use this type of converters for control of reactive power. Do you remember? At lightly loaded conditions, voltage will increase, Faraday effect. Okay, so under that conditions we use thyristor controlled reactors. Okay, I hope the concept is clear. So answer is A and B. Okay guys, see, if you have any further doubts related with this, please go through the Bimbra textbook. Don't lose your hopes regarding this. Okay, because we did not discuss this in regular course, so that is why don't lose your hope. Okay, just I want to explain some additional questions, that is why I explained. Even if you did not get the answer, don't mind it. Okay guys, okay, good. Okay, next question. Yes, all of you go through this question. A three-phase half-wave rectifier feeding RL load with freewheeling diode across the load. Firing angle alpha is equal to 60 degrees and freewheeling diode conducts for 20 degrees. Which of the statements are true? Yes guys, it is a very wonderful question. All of you try to answer this. Where is your energy levels? I am not receiving any comments. I am not receiving any answers from you. At the beginning you had very good energy. Yes, make it fast. This is really wonderful question, concept oriented question. Generally, if formula is given, you will solve mathematically, but nothing is there here. You have to understand the concept, you will get it. Yes, fast. Yes, make it fast. Okay. Yes, what's your answer? Make it fast. Make it fast. Yes guys, fast. Yes, Mr. Dilip Ranjan, your answer is perfect. Dilip, very good. Roshan, Saujanya, yes. Roshan, small correction in your answer. Saujanya, your answer is correct. Yes, all of you look here. If you, dear students, if you understand the concept, then only you can answer. Some students will try, sir, where is the formula, where is the, everywhere you will not get any formula. Understand the concept, then only you can answer this question. Yes. Now look here, all of you, very good question, wonderful question. Such type of questions they did not ask till now. Okay, look here. Now three-phase half-wave rectifier. I already said, if you understand what is the lower limit, upper limit, and if you understand the pulse number and time period, you can answer any question, whether it is 3 pulse or 6 pulse or even 12 pulse, you can answer. Only thing is understand the limits. So here, formula for lower limit is pi by 6 plus alpha. In terms of degrees, this is 30 plus alpha in terms of degrees. In terms of radians, pi by 6 plus alpha, that is the lower limit. And here upper limit formula is 150 plus alpha, otherwise 5 pi by 6 radians plus alpha, this is upper limit. So examination point of view, understand what is the lower limit formula, what is the upper limit formula. Now here firing angle is 60 degrees. Firing angle is 60 degrees. So calculate the upper limit. So 150 plus alpha, alpha is 60. So here upper limit is greater than 180. So here this is 180 degrees, pi radians. Okay, because of freewheeling diode, see whenever we have freewheeling diode, you will get negative voltage after pi, am I right? See, you will get negative voltage after pi. So up to pi thyristor T1 is conducting. So T1 is conducting from lower limit to pi. Okay, and from here to here freewheeling diode will conduct if it is continuous conduction. So if it is continuous conduction, what is the conduction angle of freewheeling diode? It is 150 plus alpha, 150 plus alpha minus 180 degrees. That is nothing but, in terms of radians, 5 pi by 6 plus alpha minus pi. So that is nothing but alpha minus pi by 6. Okay. So in terms of degrees, alpha degree minus 60 minus 30 degrees. Okay. So alpha is 60. So 60 minus 30. So 30 degrees. That means, see, if the freewheeling diode is conducting for 30 degrees, then answer should be continuous conduction. See, if the freewheeling diode is conducting from pi to upper limit, it is 30 degrees, then it is continuous. But given conduction angle of freewheeling diode is only 20 degrees. So look here, all of you look here, freewheeling diode is conducting for 20 degrees only. That means this angle is 30 degrees. See here, very interesting, right? See, this angle is 30 degrees. From here to here, this angle is 30 degrees. In that 30 degrees, freewheeling diode is conducting only for 20 degrees, and 10 degrees it is discontinuous conduction. Freewheeling diode is conducting for 20 degrees and remaining 10 degrees it is discontinuous. Remaining 10 degrees it is discontinuous. It is very interesting, right? See, thyristor will conduct from lower limit to pi. After pi, freewheeling diode is conducting. If the freewheeling diode is conducting up to 50 plus 150 plus alpha, this angle is 30 degrees. This total angle is 30 degrees. Suppose in the given question, they have given conduction angle of the freewheeling diode is 30 degrees, then answer should be continuous conduction. But given freewheeling diode is conducting, for 20 degrees. Okay. So this is less than alpha minus pi by 6. Therefore, output current waveform is discontinuous. Output current waveform is discontinuous. I hope the concept is clear. So now go through the options. The load current is discontinuous. Okay. So B is the right answer. What is the conduction angle of thyristor? Thyristor is conducting from lower limit to pi. So conduction angle of the thyristor is pi minus lower limit. So pi minus lower limit. So what is the conduction angle of thyristor? Conduction angle of the thyristor is pi minus lower limit. What is pi? 180 degrees minus lower limit is 30 plus alpha is 60. So that is 90 degrees. So conduction angle of the thyristor is 90 degrees. So C is also right. So it is MSQ question. So option B and C, two right answers. MSQ question. Really, this is wonderful question. Only thing is, students should understand the basic concept. Without understand, see, I did not draw the waveforms. No need to draw the waveform, my dear students. No need to draw the waveform. Understand the lower limit, understand the upper limit. If you understand the limits, you can imagine the waveform and you can answer the question, any type of questions in three phase, whether it is three phase half wave rectifier or whether it is 6 pulse converter. Just based on the limits, you can answer every question. I already reminded you in regular course and also QRG program. In rectifiers, you can answer many questions just based on lower limit and upper limit. Right, guys? Concept is clear? Okay. If you have any doubts, I will further explain once again. Right? Very good question. So till now we did not get this type of questions. Okay. So chances are there for such type of questions, generally in MSQ questions. Okay. So concept is here. From lower limit to 180, thyristor will conduct. After 180, because of negative voltage, freewheeling diode will conduct. If the freewheeling diode is conducting from 180 to 150 plus alpha, this angle is 30 degrees if you calculate. If the conduction angle of freewheeling diode is 30 degrees, then it should be continuous conduction. But in our problem, freewheeling diode is conducting only for 20 degrees. That means remaining 10 degrees it is discontinuous. Guys, concept is clear? Okay. Shall we switch on to the next question? Yes, I hope you understood the concept. Okay. Very interesting, right? I did not draw the waveforms. Dear students, you cannot draw the waveforms when it is asked for 1 mark. Understand the concept. You can answer any question in rectifiers. Very wonderful tips I have given in regular course regarding these concepts. Okay. Yes, guys. Yes, go through the question number 12. Question number 12. Yes. Question number 12. It is very easy question. I hope many of you can do this one. Yes, fast. Make it fast. Very easy question. Many of you can do this question. Make it fast. Yes, make it fast. Yes, what is the answer? Yes, students, make it fast. Yes, see here. So in this case, we have to find out the average power loss in a thyristor. See, average power loss in a thyristor. How to find average power loss? Thyristor is conducting during the interval 0 to pi. See, how much time thyristor is conducting? From 0 to pi. After that it is off. Time period is 2 pi radians. So average power loss means 1 by time period. Thyristor is conducting 0 to pi, integral 0 to pi, integral 0 to pi. Equation for voltage across the thyristor, current passing through the thyristor d omega t. Just solve this, you will get the answer. Okay, so that is the formula for average power loss. This is nothing but instantaneous power loss expressed as function of time. Yes, make it fast. I have given hint. You try this. What is the relationship between voltage and current? See, you can use this VI characters of SCR. From the VI characters of SCR, you can write down the equation of voltage. Okay. So what is the equation and what is the slope of this? You can write down the equation of this. Equation of this one is, see, this is 0.8 volts. 0.8 volts plus this difference by this difference, inverse slope. This is 2 minus 0.8 by 100. So m into x is current, equation of anode current. So equation of voltage across the thyristor, 0.8 plus 0.012 into anode current. Anode current is nothing but thyristor current. Here anode current is nothing but thyristor current. And what is the equation of thyristor current? It is sinusoidal function. Okay, so here equation for thyristor current is peak 8 into sin omega t. So that is the equation of thyristor current during the interval 0 to pi. Okay, so let us substitute here. Average power loss is equal to 1 by time period is 2 pi. So integral 0 to pi. So during the interval 0 to pi, equation of thyristor current you can substitute here. Voltage of thyristor is 0.8 plus 0.012 into thyristor current multiplied by thyristor current into d omega t. Okay. Yes, simplify this. Substitute the thyristor current formula here. 1 by 2 pi integral 0 to pi. First 0.8 into thyristor current. No? Let us separate it. Two terms we have. 0.8 into thyristor current. Equation of thyristor current is 80 sin omega t d omega t. Okay, plus integral 0 to pi. Now 0.012 into it square. What is it square? 80 sin omega t whole square, sin square omega t d omega t. Okay, this is 80 square you have to write. Yes, please calculate it. Tell me what is the answer here. Yes, 39.57 watts. If you calculate 39.57 watts. So very easy question, very simple question. Only thing is calculation part. That means just only calculation part here. Otherwise it is very simple. There is no any difficulty here. Answer is 39.57 watts. Very simple question, guys. There is nothing here. Because I cannot ask all tough questions. People will lose hope at the end. That is why some simple questions also I have given here. And let us see the last question now. Yes, go through the last question. Guys, I hope everything is clear to you. Okay, fine. Yes, very simple question. Basic formulas. Okay. Now last question. Yes. Now see the last one. Which of the following statements are true in a 6-pulse converter? Which of the following statements are true in a 6-pulse converter? Yes, what is the answer? This is related with 6-pulse converter. Okay. This is actually related with a 6-pulse converter. It is actually related with a 6-pulse converter. Now, in statement A, maximum possible firing angle with pure resistive load is 120 degrees. I think I have done this. See here, for resistive, wait, small correction. So here also, see, for resistive load, you can vary the firing angle only up to 120 for resistive load. In the case of inductive load with continuous conduction, in the case of inductive load with continuous conduction, you can vary the firing angle up to 180 degrees. So statement A is right or wrong here? Go through the statement A. Maximum firing angle is 120 for R load. Yes, for R load maximum firing angle is 120. Yes, statement A is right. I have given this. If it is 3 pulse converter, it is 150. If it is 3 pulse, it is 150. I have given this in the regular course, guys. Do you remember? Yes. Now, the instantaneous output voltage due to the source inductance during overlap period is 0. Statement B is right or wrong? Yes, the instantaneous output voltage due to the source inductance during overlap period is 0. Is it right or wrong? Statement B is right or wrong? Guys, answer to me. Statement B is right or wrong? Statement B. Statement B is right or wrong? Statement B is right or wrong? These three statements are related with source inductance. Okay. Now see here. During overlap period, 3 thyristors will be conducting. Okay, 3 thyristors will be conducting in 6 pulse. In 2 pulse bridge rectifier, all the 4 thyristors are conducting. Okay, in the waveforms I have done in the regular course. Please go through the waveforms, right? Okay, please go through the waveforms. So 3 thyristors are conducting. So during overlap period, 3 thyristors are conducting at a time. D is also right, C is wrong. And in B, during overlap period, we have to take the mean value of the output voltage. No, see, the output voltage during overlap period, it is the mean value. It is the mean value of the output voltages. It is the mean value of output voltages by the conducting thyristors. It is the mean value by the conducting thyristors. We have done the waveforms. So this is actually wrong statement. So A and D. So MSQ question. So A and D is the right answer. Okay. Option A and D. Option A and D. Okay, students. So I hope you might have enjoyed this session. Okay. Really, it will benefit you. No doubt in that. And one more important advice to you guys. Power electronics, don't get worried. Just go through the QRC program. Rectifiers, inverters and choppers, mainly these 3 areas. 3 hours topic. You write down the short notes referring the QRC program. Very clearly I mentioned what formulas we have to memorize, how to remember the formulas, what waveforms we have to memorize as per the examination point of view, and remaining formulas how to get them. So such type of tips I have given in QRC program. Just 3 hours. Okay, 3 hours topic. And after that, additionally, you have to go through the previous GTQ courses. Go through the previous GTQ 2021 and also 2022. Don't miss these topics. If you have sufficient time tomorrow, just what we have done today, tomorrow 2021 you solve. Day after tomorrow 2022 you saw it is available in YouTube channel Made Easy. Last year and before we have already done this in the YouTube channel, okay, and definitely I hope that with this your confidence level might have increased. Always be happy, and main thing is be healthy. First be healthy, maintain proper diet. Before examination, sleepless nights without proper diet, your health will spoil, okay. So my sincere advice to you guys, maintain your health and plan the things in a proper way. You cannot read the whole regular notes now, okay. For every subject in Made Easy we have given QRC program. Go through the QRC program. Subject will be very short. Each chapter you will get 1 page. So before examination you can summarize the formulae, you can understand everything, okay. You will be more confident. Already you have practiced everything, right. Just be happy and plan the things in a proper way. Be healthy, right students. All the best for your examination, okay. Thank you so much for your patience listening to my lecture. Once again, thank you students. Enjoy. Bye bye. Good night students. So finally conclusion, power electrons is the easiest subject what I feel and what you feel, right. Thank you.